share my screen. All right. Going to look at gawk today. Gawk is a command line program that is basically made for manipulating columns of data. Don't ask what the name means. I think the original tool was AWK. I think it's an acronym for the authors. The G in gawk just means that this is a GNU's version of awk. So if you see awk, like if you're looking up how to do stuff and you see instructions for awk, that's the same tool as gawk. There's another one I believe that is on Mac, that Mac OS has, that's probably like a BSD version. So there's a couple of different programs that basically do the same thing but have slightly different names. Gawk is the one that's installed by default on Linux. So far we've been doing, we learned how to construct pipelines. The nice thing about pipelines is it allows you to take some small, simple tools that do specific things and connect them together. So we've, for example, cut a column out of some data, sorted it, and then printed the last 10 lines so that we could see what the maximum value in that column was. Gawk is a tool that is almost always used in a pipeline. Now, you know, it's actually pretty powerful, so some people use gawk to do a lot. But typically what we're going to do, and what I usually only find a reason to use gawk for, is to do a little bit of manipulation in a pipeline. And gawk is the thing that you're going to use if you want to manipulate columns. Like, for example, if you had a data file that contains some columns that you wanted to extract a couple of, maybe rearrange, or even do some transformation, like multiply column 2 by a constant, then gawk is the tool that you're going to use. It is much more powerful than cut. I almost always use gawk instead of cut, unless I really don't, you know, I don't feel like typing out these curly brackets. The basic syntax is this. The gawk command takes several arguments. The first argument is always the quote gawk script, meaning gawk's going to interpret this string and then it's going to do some stuff. And then you can give it file names. If you don't give it file names, it's going to read from standard input, just like all of these other command line tools that we've been working with are. So this example right here would print out the first column in file.txt. That would give you the same result as if you just catted file.txt first and then sent the outputs to gawk. So you don't have to give gawk a file name. The script needs to be wrapped in single quotes, not double quotes. So I've got a single quote here and a single quote here. If you're going to use anything that refers to the column number, which you have to refer to the column number using a $sign and the column number, then it's got to be wrapped in single quotes. If you don't wrap it in single quotes, the shell will try to replace $1 with the first positional argument, which doesn't exist when you're just interacting with the command line. And so it'll get replaced with a blank. So you got to put single quotes there so that the shell doesn't try to do that. Actually, what we have is the stuff inside of these curly brackets, that is the gawk command. And you can also prefix these with conditionals. So I'm going to go through several examples that show how we would use gawk. But here's a nice example. Let's say that I only wanted to print the values from the first column that were greater than 10. The gawk command that would do that would be a conditional first. So this gets evaluated, and if this is true, then the stuff inside of the curly brackets will be ran. And this is saying if the value of $1, which is the first column on every line, is greater than 10, then print $1. So that's going to print the first column's value if it's greater than 1. Some nomenclature, or I guess vocabulary in gawk terms. Gawk refers to, it's sort of, you know, built to deal with fields and records. So gawk's going to read a text file. Every line it refers to as a record. So if you've got 10 lines in your text file, you have a data file that has 10 records in it. Records are separated by fields, which we refer to as columns. So within a record, you have multiple fields, and you can manipulate those fields. That's the gawk vocabulary. So that explains when we see, for example, the variable that contains the record number. It's going to be NR because it's the number of record that you're looking at. And then when we look at how many fields are there in a given record, the variable for that is going to be NF. So gawk was basically, sort of geared towards manipulating data that is contained in text files, each record on a line. Each record has multiple fields. So I'm going to open up the I'm going to go into the sandbox directory, and I have a directory in there called gawk with some example text files for us to look at. So I'm going to go into that directory. Now, as usual, I have a lot of, I guess as Corey would say, a lot of dead horse to beat here. I have a lot of examples that are the same thing over and over and over again with slight things tweaked, just so that we get, one, this will be on record. You can go back through and watch this at a later date, but just to show like the differences between cut and gawk and why we would use gawk over cut in certain instances. So let's look at what we have in here. I have several different files that basically just contain data, but I have different files that contain data in columns that are separated by different delimiters. So I've got a text file here where the columns are separated by spaces. That's what we've done before, and we remember that we had to tell cut to use a space as the delimiter when we did that. I've got some that are separated by tabs, double spaces, space tabs, and I even have some comma separated data files. So for example, if I just look at the top of this tab separated.txt file, this is what it looks like. It's got 6 columns in it, a time column, and then 5 trial columns. The tabs are nice in that, the shell will format a tab with unequal spacing, and typically that means that you'll get text lined up. If certain columns are too long, then even tabs won't get them aligned correctly, but this would be the main reason, I guess, for using tabs. I typically don't like to use tabs because you can't tell that there's a tab there, and a tab and a space aren't the same thing. That's what causes cut to fail if you try to cut columns based off of spaces and you don't tell it to use a space. So I would get the exact same output here if this was actually 6 spaces instead of a tab, right? And then basically manually padding all of this with spaces as opposed to tabs, and I can't really tell the difference. But this is what a tab separated file is going to look like. I'm going to take that tab separated file and I'm going to send it to cut, and I'm going to pull out the first column. Now, by default, which we haven't actually done yet, but I told you, by default, cut is going to separate the columns by tabs. So this is exactly the format that cut knows how to deal with. So if I give cut TAC-F option, tell it to cut out column 1, it works perfectly fine. For the rest of these examples, I'm going to run the output of the command that I use through head, so that I don't just get a big long string of lines or numbers that I can't tell which column it was. So if I run this through head, I'll just get the top 10 lines their output. So this is the first column, it's the time column. This is a common thing to do when you're trying to develop a pipeline. Run the output through head at the end, and then when you finally get it fixed correctly the way that you want it, you can just delete the head command at the end. So now if I run the cut command and I tell it to cut out column 2, I should see trial 1 show up. I can give multiple columns, right? So column 1 and 2, we'll print out those 2 columns together. If I wanted to skip a column, I could give column 1 and 3. Right, that would skip a column. I thought, which doesn't appear to be the case, that you could switch the order of the columns with the cut command, but apparently not. Apparently, the argument to the TAC-F option is just a list of column numbers that you want printed, and then those are going to be printed in the order that they appear in the text file. So I have a space separated text file here. This now is not aligned because it's a single space that separates all of the columns. And so it doesn't look pleasing to the eye, but we can always run that through the column command, remember, with the TAC-T option, and then it would align everything for us. And the problem with this space separated file is that the cut command does not interpret spaces as column delimiters. It interprets tabs as column delimiters. And if I try to cut out the first column, I just get all of the columns printed. That's because it hasn't ran into a tab, and it basically treats that as the, basically the only column of data in the file. So if I want to use the cut command, I have to give it an additional option. And that additional option is that it needs to use a space for the delimiter. And recall that I have to quote that space so that the shell will actually treat that as a space and hand it to the cut command. And now it works, right? I get the first column here. I can pull out the second column with TAC F2. And that's the only modification that I need to make for the cut command. The problem comes up when I start having like multiple delimiter characters between columns. So this example that I have here is double space separated. So instead of a single space between the columns, I just have two spaces between the columns. I can imagine if I was going to manually align these columns, some columns might be separated by 3 spaces, some might be separated by 2 spaces. You'd have unequal number of spaces between columns. If I take the double space separated file and I run that through cut, one, I have to tell it to use spaces as the column separator. If I print out the first column, I get exactly what I would expect. It prints out the time column. If I try to print out the second column, I get something that I don't expect in that I just get a bunch of blank lines. And so what's happening here is that there are 2 spaces between the first and the second column, what I identify with my eye as the first and the second column. Cut is taking the empty space between those 2 spaces, or the empty character between those 2 spaces, as the second column of data. So I would need to tell, actually, I'm not even sure. Let me see if this works.
2 spaces and it says it must be a single character.
Exactly. You can't give it multiple spaces for the delimiter because it only accepts a single character. That's right. So if you have double spaces, then all of your column numbers are going to be shifted by, well, different amounts. The second column is actually column 3 according to cut. The third column is going to actually be column 3, 4, 5 according to cut. The other thing that I could do is I could have a mixture of spaces and tabs. So let's say I've got columns that have tabs and spaces in them. Now, this is really, I mean, it basically looks exactly as just the tab separated one, but I actually have some spaces in there, some tabs in there. It's a mixture of spaces and tabs. I send that through the cut command. Looks like the first column must be separated from the rest by tabs. Second column must be separated from the rest by tabs as well. Do I actually have, let me see if I actually have tabs, any spaces in there. So I'm gonna cat space tab, run that through head, and then I'm gonna grep for a space. It's probably highlighting a space in red so that I can't actually see it. Well, let me open it up in a text editor and search for a space. Okay, so I got spaces here. I've got spaces after every number, and my tabs are after the spaces. So it goes a space and a tab, which is why I can't see that it's doing something strange, because the first column then is going to have a space after it, and I don't see that on my command line. So this was a crappy example, and I apologize. If I was able to quote these, for example, what I would see is that there's a space character right here. Actually, I can see that just by trying to highlight it. So there's a space character that shows up after this. So if I use cut on that, I'm going to have some spaces afterwards. If I had like space, tab, space, or a couple of tabs and some spaces, I'd have the same problem. If I had 2 tabs between any 2 columns, cut is going to take that whatever is in between those 2 tabs, including nothing, and it's going to treat it as its own column. So it's not very flexible, really. And so the first thing that we would like to use gawk for is to basically give us a flexible version of cut. Column 1, based on space separating, is the same as it was for tab separating. But column 2, I should see, there we go. Now I see a tab here in front of column 2 because there was a space right in front of that tab. All right. So let's use gawk instead. Now, to use gawk as a cut replacement, very simple. I'm just going to tell it to print out which column number I want. The things that are important are, again, you've got to have single quotes around this, this command that you're giving gawk. You got to have curly brackets around it, and you have to print. So gawk can do more than just print. So the print is a statement that says, take this value and print it to the screen. You can do other things with gawk, right? So gawk has a sort of a little mini programming language that it supports, and the print command is something that prints something straight to the command line. So this would be a gawk or a cut replacement that pulls out the first column. We can see that it works for tab separated columns, right? So it works on the tab separated.txt file. I'm going to do the same thing with the space separated file. Print out column 1. That works. So already it's better than cut because I don't have to specify what my delimiter is. I just say print out the first column. Gawk treats any white space as the column separator, and it treats multiple white spaces together as separating columns. It doesn't put columns in between consecutive white spaces, for example. So in the space tab file, it works, and even in the double spaced file, it would work. So this is nice. As long as I have just white space separating characters, the gawk command will cut out first, second, third, fourth columns. Bless you twice. All right. I've got the, what did I do here? The tab separated. What's that? Ah, yes, I got double quotes here. So if you do double quotes, you might get something like this. And this is confusing if you don't know what's going on, right? It doesn't, it's like, okay, well, why is it not interpreting the columns correctly? And the answer is that the shell is taking that string before gawk gets it, and it's replacing that $1 with, in this case, nothing. And so I can do, for example, let me do another gawk command, a gawk command that works. So I'm going to do single quotes. The print command with nothing to print will just print out every column. So that's exactly what's going on here. Right? That will print out every column. What does print $1 get expanded to? It gets expanded to print with a space. That's because $1 is a positional parameter that the shell interprets, right? In a shell script, that would be loaded with whatever the first argument passed to your script was. Anything I can do in a shell script, I can do on the command line. So these variables are also variables that can be defined on the command line. And the shell is trying to do variable substitution. In order to keep it from doing variable substitution, I've got to do quotes with single quotation marks. Now the $1 doesn't get replaced. That's true for all variable names, right? $1 var does not try to do variable substitution if I single quote it. It does try to do variable substitution if I double quote it. Rather than complaining that the variable doesn't exist, the shell just expands it into a space. Very convenient for hiding bugs. If I define, I don't know if I can do this. Let's see if I can, if I define this variable to be one commands not found. Nope, so I'm not able to define the positional parameters, but I am able to try to dereference them, even if they're not, even if they don't exist. So we got to use single quotes for that gawk command so that that doesn't happen. Anything with a $sign in front of it is going to be replaced by the shell. So here's a nice thing. I've got tab separated file. If I want to cut out the second column, I just print $2, and gawk's going to work on all of these. Whereas cut, I had to specify delimiters. Gawk will work on all of these files. Any consecutive white space is treated as a single delimiter. I can print out multiple columns. If I'm going to print out multiple columns, I separate the columns that I want to print out by a dot or a comma. Right? So I just give it a list of columns that I want to print out, just like cut. Unlike cut, I can change the order of the columns. That's very handy. So let's say I want the first and the second column, but I want to switch the order. All I have to do is give the columns that I want to print in the order that I want to print them, and gawk will print them in that order. So now I've swapped the second column and the first column. And then I can also do things like multiply the first column by 2 before printing it out. And I get 0.2, 0.4, 0.6, 0.8. You can see this top one, which was the header, right? Apparently a string multiplied by a number is just replaced by 0 with gawk. If that's not what I want, then I'm going to have to do something that handles that header specifically, something that either doesn't apply this to that header or removes that header before it runs through gawk. There's a special column number, and gawk calls these fields. So in the previous examples, I've been printing field 1 and 2 for every record. Field 0 is all fields. So $0 will print out the whole line. And that means that you can add stuff to the front or the end of that line if you wanted. So for example, I could print out the first column and then all of the following columns, right? And it would tack on the first column, and then it would give me all of the columns after that, or I could sandwich them in the first column for whatever reason. So $0 can be used in the print command, and it's just, basically all of the records, or excuse me, all of the fields together are inserted for $0. Yes, Todd?
You also click on a string to that, so you want to label the
So I could do something like label and get a label added to the front of every string. Yes, Corey?
Why does it shift over, like on the end there, all those times or whatever?
That's because this is tab separated. And so if certain lines get too long, the tabs don't align anymore. I don't know what that limit is, but tabs will sort of expand. They're sort of like variable sized spacings, except they don't expand to infinite. So it's like, they'll go from like 1 to 4. And if you actually have something that's longer than 4, then that tab won't align it anymore. So that's what's going on here is my tab alignment's breaking. So for every record that gets loaded, there are some variables that get defined by gawk. And you can set variables in gawk, right? And one of the special variables is capital N, capital R for number of record. And that is replaced by the number. It's essentially the line number is what it is. It's replaced by the line number. And that happens for every line. And this gawk command gets ran for every line. And so you can put line numbers at the beginning of every line by just printing out NR and then printing out $0. Right? That's one thing that you can do if you wanted to create a file that had numbered lines. But the other thing you can do is, which we'll see, you can decide whether or not to print a line based on that record number or that line number. The other special variable that comes in handy sometimes is called NF, and that's the number fields. So you've got the record number that you're looking at, and then you've got the number of fields in that record that gets stored in NF. And if I print out NF and then the rest of the records, I get a 6 in front of all of these. That's because there are 6 fields in each record. 1, 2, 3, 4, 5, 6. Huh?
And you can put in white space with like /T or /N, right?
A /T is the tab character.
Right.
That's how you type out the tab character. /N is a new line. Yep.
I was making sure that.
Yeah. So if you want to add a tab, like if you wanted to put a tab in, you'd have to do a /T to get that in there. This is a really handy feature. So the field number can be used as a column number. So the 6th column, right? This is column 1, 2, 3, 4, 5, 6. The 6th column here can be referenced with $NF, which means that if you don't even know how many columns you have, you can always get the last one by referencing $NF. So that will pull out the last column. If I look over here on the very far right, 096, 096. So that's probably the main thing that I use this NF variable for, is if I've got a file that I know whatever the last column is, that's the column I want. You can pull that last column out with the $NF variable. Let's look at another file format that's very common with data, and especially when we start, like eventually, not very long, I mean today or tomorrow, we'll see how, all right, let's assume that I've got, somebody has sent me an Excel file, right? So they got all their data in an Excel spreadsheet. How do I get that into a text file that I could use GNU plots to plot, for example? Well, the easiest way is to first get it into a CSV file. So that means comma separated values. If you get it into a CSV file, then it's just plain text with comma separated values, and then you can use all of these same utilities to manipulate the data. If you look at a CSV file, this is what it's going to look like. So now instead of the columns being separated by white space, they're separated by commas. The benefit to this is that you can have white space in your columns now, right, without that confusing your parser. So for example, I could use trial space 1 in this comma separated value file, and that would be fine. Anything that tries to use column or space as the column separator, though, is going to be tripped up by that. So this is a common format, and you can export an Excel spreadsheet into comma separated value files. Right? There's a save as option where you can say, hey, save this as a plain text file with comma separated values. Yes,
you can also export it as tab delimited and space delimited files.
Exactly. Yeah. You can do tab delimited, space delimited, comma separated values is probably the most common one that's used. Common, not common. Now, the problem here is the gawk by default is going to treat white space as a column separator, and this is not going to be parsed as multiple columns. Cut would do the same thing, right? I would have to tell cut to use a comma if I wanted to cut out a column with the cut command. But it's fairly simple to tell it to tell gawk to use a different character. And the nice thing about gawk is you can use more than just a character. And I don't know the details of this because I rarely run into it, but I believe that you can even define like a pattern. So like a regular expression that can be used to split each record into fields. Now, don't hold me to that. I'm not certain if that's true. But gawk takes options. TAC capital F is the field separator option. You give it a comma, you tell it to print out column 1, you can now print out column 1 of a comma separated file. Gawk separates the idea of input field separators and output field separators. So when I print multiple columns with a comma, what I'm actually doing is saying print out column 1, print out column 2, separate them by the output field separator string, whatever that is. By default, that's going to be spaces. So even if I have a comma separated file, if I print out columns 1 and 2, I get a space separated output. If I really want that to be comma separated output, then I'd have to set the output field separator. You all right over there, Derek?
No.
Get stung in the eye by a bee, or?
No, my cold's making my right eye.
Okay.
Really
Looks
bad.
like you got some wheat dust in there or something
Yeah.
like that.
Like lectures that inspiration.
Yeah. Oh, God.
It's been doing this since like noon yesterday.
Oh.
It's really annoying.
I digress. Did I hear a question over there, or was it just a general comment of Derek's poor state?
I couldn't figure out why mine wasn't working inside of lowercase f.
Yep, needs to be uppercase F.
That's not working because my computer's soaked in tears, apparently.
Short now.
Columns.
That joke's really getting to you, isn't it? Now, if I do, so I do an input field separator that's a comma, and then I print $0, then that output is still comma separated. All right, but if I print multiple columns separated by commas, it's going to be space separated. All right, so let's look at the conditional part. If I go back to my slides, the general form of the gawk script or gawk command, I guess I should say script because the stuff inside of curly brackets are commands. The general form is a condition. So is this true? And if it's true, run these commands. And you can give multiple commands, and you can also give multiple conditions. But we're just going to look at a couple of simple cases. What is a condition? It's something that you're checking to see if it's true. So for example, is the record number of this record greater than 10? Meaning, is this on line 10 or above? Or I guess on line 11 or above. That would be a condition. And you can have commands only run under certain conditions. That's what this command here is going to do. So I've got I'm going to cap the space separated text file. I'm going to print all fields in the records, but they're only going to be printed if this condition is true, if $1 is greater than 2. So that means if the first column has a value that is greater than 2, print it out. We've been looking at these cases where the first column starts, I mean, we've been running this through head. And the first column you can see starts out at 0 and then goes to 0.1, 0.2. So if I run that through a condition, only print if the first column is greater than 2. I haven't ran this through head either. So this is basically the last several lines of the file, only the cases where the first column is greater than 2. So you can imagine, I mean, I can do things like, well, let's see what is the value of the second column for every case where the first column is greater than 2. And I can just print out second column values for the case when the first column is greater than 2. If I want to have more than one thing be true, and this isn't a good example because I know that none of them are less than 6. Let's do 2.3. So let's say I want to check multiple things. I just separate the multiple conditions with an and sign. Well, I guess depending on what I want to happen, I'm either going to do an and or a bar. And this is just the syntax that's used by most programming languages to say, is this true and this is true? So this condition is saying, I want records that have a first field greater than 2, and also the first field is less than 2.3. So I'm only going to look at cases that are between 2 and 2.3. The exclamation. Or I could just turn around that. I can make that less than instead of greater than.
So,
Yes, Corey?
pretty sure you can do this, but can you put like a dollar or an NR in that print so it'll print like which row it was in?
Oh, yeah. Let's just try it.
So,
So I'm going to print NR here. So this should show me if I'm actually printing lines that are in the middle of the file or not. So I only get 2 lines. This is the first column that was checked. 2.1 and 2.2. Those are between 2 and 2.3. And those are lines 23 and 24 of that file. So this is really handy, especially if you're working on data that you're trying to get into something that you can plot, for example. Say, okay, well, I want to ignore all the stuff that's less than this, ignore all the stuff that's greater than this, and then just take this data in between to generate a plot using GNU plot, of course. Yes?
Is there going to parse the string into an integer?
Parse it, you mean take the string and treat it as an integer?
Yes.
Which string?
Just any data point that's in there, basically.
I would guess,
I guess that would work for this. But
which I don't know. But, so there's $1. Let's just see if there's an int function. Looks like there is. So yeah, you can treat it as integers. Corey? Stretching? Oh,
Yeah.
just be.
He's gonna start crying.
An integer, yes. Huh. Hold on, let me see here.
that character says 0. Why?
Because A is not an integer.
You got me. Because that's how Gawk decided to treat it.
Because whenever you sort something, it'll put little a is less than, or is less than big A, which is less than B, which is less than big A. Big
I would say Gawk's meant for manipulating numbers. If you need to do some string stuff, don't use Gawk. That's what I would suggest. All right, let's see what else we got here. Here's a way to basically replicate head. So I can say Gawk only if numeric, or tell Gawk to print the entire line or the entire record according to Gawk if the line number is less than 10. So there's the first 10 lines. I could replicate the anti-tail, right? So like, what if you wanted to print out, you didn't want just the last 10 lines, but you wanted everything but the first 10 lines, right? How do you do that with tail? Well, there actually is an option to do that, but you have to, I mean, every time I try to do it, I have to go look it up. But I could just say, hey, print out lines where the line number is greater than 10. So this is whatever the, however long the file is, all but the first 10 lines get printed here. Sometimes I want to take, like for example, and you can do this with head and tail, take a slice of a file. Like, so let's say you want lines 20 through 25. Well, you run it through head first to get the first 25 lines, then you run that through tail, get the last 5 lines, and you end up with lines 20 through 25. Same thing here. I can use Gawk to print out lines that are the record numbers that are greater than 10. When I send that output to a pipe, everything gets reset. So I'm basically using Gawk multiple times here. Every time Gawk runs, all of the record numbers, field numbers, everything that Gawk uses for interpreting this data is reset. So this first one prints out the first 10 lines. This next one prints out lines that are greater than 10. So that's going to remove, guys, is that going to do anything? Wait a minute. This first one is the lines greater than 10, and then it's lines less than 10. So that's as if I ran tail and only printed everything except for the first 10 lines. Then I extracted the next 10 lines. So that should be lines 11 through 20. And then I'm using Gawk again to rearrange the columns. So this should give me 10 lines, and I'm gonna print columns 3, 2, and 1 in that order. So I've changed the order of the columns, 3, 2, and 1. And I've only got 10 lines here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 actually. And then you can see this last column here. These are the numbers that were in the original first column data, right? It started at 0.1, goes all the way up to 2.9 by increments of 0.1. So it's 0.9, 1.0, 1.1. So I can do, I can use, and if you need something fancy done, it's often easier to just use gawk more than once in your pipeline than to try to cram everything into a single gawk command. And if you get to the point where that's not fast enough, then you need to take the time to figure out how to use gawk a little more efficiently. Everything that we're going to do, it's going to be plenty fast. All right, so here's what I got for us to work on. The sandbox contains a file that's named Ocular Transmission Human, CSV, and that's in the data directory. What is today? 13. Data. All right, so I'm going to look at.
You spell ocular with a 0?
No, it's a capital O.
Yeah, it doesn't have the little dot in the center that the zeros do.
In certain fonts. So I'm going to open up this file in LibreOffice, which is the Microsoft Office
That's why I can't see the.
equivalent. And this is what the file looks like. So this file is basically distributed as an Excel spreadsheet, although it's a CSV Excel spreadsheet. And what it is it's a catalog of ocular transmission through the various tissues of the eye as a function of wavelength. So different colors are absorbed by the material that makes up the eye by different amounts. So for example, green. Green is 532 nanometers. There's a range that we would all call green. 532 nanometers, if I looked at green light coming in from some green light source, and I measured the amount of light that reached my retina, it would be a different amount of light compared to if I was looking at red light, 532, right? So different amounts get absorbed by different wavelengths get absorbed by different amounts, and the wavelength is the color. So the wavelength your brain directly interprets as a color. Now, most of the visible all gets to the retina. If it didn't get to the retina, it wouldn't be the visible, right? So it's obviously going to get to the retina, but it doesn't 100% get to the retina. Your eye absorbs some of that stuff. Most of the absorption comes from the vitreous. The vitreous is the goo that makes up the middle of your eye. It's basically like water, and that absorbs some of the light. So this is a catalog of measurements of transmission for each of these different tissues. So the cornea is the first layer. That's the part that you can actually touch with your finger. Behind that is the aqueous. That's a fluid that separates the cornea from the lens. Then the lens material. Then you have the vitreous, which is the majority of the jelly. Has anybody seen, do you guys remember Rachel Schmidt's Lydia? Did anybody go see Lydia in her lab when she was dissecting cow eyeballs? That jelly that comes out, that's the vitreous.
I've dissected it.
That's delicious.
It is. It's a delicacy in many labs.
Yeah.
And then the eye total transmission is right here. So this number here should be the product of all of these. So this is what you'd want to know if, what percentage of light makes it to all the way to the retina. This is the transmission. So this right here basically says no light makes it to the retina for this color. 305 is ultraviolet. Your lens and your cornea basically block ultraviolet. So basically none of this light makes it to the retina. You go down here, visible starts around 390 nanometers, which is 0.39 micrometers. So here I have a transmission coefficient that's 0.2%. Here I'm getting up to 12%. 40%, right? So you see much higher transmission coefficients here. It's still not 100% though. So this is where we get most of the light coming through, and then this goes back down, I believe. Let's see.
Yeah.
Here it's going back down. So now I'm getting into, this is really long wavelength stuff. 700 is about the longest wavelength that I can see, but the infrared, which has wavelengths longer than 700, still can transmit significantly to the retina. So this is still light that is invisible, but is being transmitted to the retina. And now we're getting into things that are hardly transmitted. So that's what this data file contains. This data file, if you just cat it, or if you run head on it, you'll see that it's just a comma-separated file. So what I want us to do is, from the last column, which is the last column in the this file here, right? So this last column is transmission of the eye, which is transmission that gets to the retina. That would include all of the transmission from all of the stuff in front of the retina. Use gawk to create a file that you can use to plot the transmission versus wavelength. So you should be able to see a function that is, here's transmission as a function of wavelength. When it's high, that means it transmits a lot. When it's low, it doesn't transmit very much. And if you plot that as a function of wavelength, then you get a graph that shows what colors make it to the retina, what colors don't make it to the retina. And then take the visible spectrum, which is the wavelengths between 0.39 and 0.7 micrometers. That's the units that are in that file, and calculate the average transmission for that. So only in the visible wavelength, what is the average transmission of that? Now, if we were doing this, based on our old ways, we would go into this Excel file and then we'd say, okay, well, let's see here. Where's 390? We'd go do this by hand, right? There's the first one that I want. And here's the last one that I want. This tells me the sum. Is there some way that I can tell it to do the average? Okay, so there's my average, right? So I know what that average should be. But really what I'd like to do is have this automated, because what if I got another spreadsheet that was for rabbit, or I had another spreadsheet for cats or rhesus monkeys or dogs or something? Well, if I had a script that just parsed this and then calculated the average, I wouldn't have to open up every one of these files and do this by hand. So that's what we're gonna do.
So you only want the fifth column then?
For the plot, I want this column here, yep. Yeah. And then for the average, I just want a subsection of that fifth column.
Where we're going to plot the fifth column against the...
And plot it against this one right here, wavelength, yep.
Oh, so we're doing the Vitreous column?
We're doing this last one,
That's the sixth, isn't it?
Yes. Actually, it was the sixth.
whatever that one is.
Yeah,
1,
6.
2, 3, 4, 5,
Sorry, I had
6. I only know that because I've been helping Quaid count.
Out of the year.
Yeah. And that's our time.